So I'm Matteo Peruzzi.
And I'm Matteo.
And we are doing diagram C, and we're using the Thevenin theorem to solve it. Okay, so the first step in the Thevenin process is to calculate RTH by removing RL, and also at the same time and then over here we're going to zero the sources, and so that's what this diagram is. So the first step is we have to find RTH, so we remove RL here, given points A and B, and then we also zero the sources on each side. And in this case, R1 and R2 here are in parallel with regards to A and B. So we get an RTH of R1 in parallel with R2, which ends up being 1.32 kiloohms.
So here we're going to calculate VTH, and for VTH here we have RL, which is open, and we have both sources here, which are 5 volts. Since they both move in the same direction, we can add them, so we get a total voltage of 10 volts. And then if you know the resistance from here, if you know the voltage from here to here, we'll know what the voltage is here. Or if you know the voltage from here to this point, we'll know the voltage here also. So we can use either side to measure the voltage using the VDR rule, as seen here. Here the total voltage is 10. The resistor we're using is R1, which is 3.3, and the total resistance is 5 kilo ohms. And also here, the total voltage is 10 volts. R2 is 2.2, and the total resistance is 5.5 kilo ohms. So over here are V1 and V2. You can use either, which is 6 volts and 4 volts. As you can see here, for this part, it goes from the positive. It goes from the negative to the positive. So that makes this plus 5 volts. And as you can see here, it goes from the positive to the negative. So that makes this negative 4 volts, which is equal to 1. And here for this also, this goes from the positive to the negative, so that makes this negative 5 volts. And this goes from the negative to the positive, that makes this plus 6 volts, which is also equal to 1. So you could use either one of these, so then we get VTH, which is equal to 1. And then here's the diagram. And then here's showing VTH, which is equal to 1 volt. And here's RTH, which we calculated earlier, 1.32. And here's our RL, which was given 4.7 volts. Alright, so for our circuit, we need to make the C diagram, and we gotta solve it using Thevenin. So here's the diagram on the breadboard. As you can see, we modified our circuit to make it more simpler. Some of the other jumper wires have been removed, and now we only got these 2 jumper wires, and these 2 are in parallel. They are now connected to this ohm meter. So both will receive current from this ohm meter, and we'll be able to know the RTH from RL, which is 1.32 kilo ohms. The VTH across RL, which is here, and that's your load resistance. The VAB value over RL.